We're going to do problems identifying if a reaction goes via SN1 or SN2 in predicting the products, including stereochemistry. So we're going to look first to do that analysis, what is the reagent, and we're going to be looking at the structure of the, say, alkyl halide, if that's the case. So let's go on my first problem here. And you read it, what I have. So let's do that. That's a bromide. And we see here the sodium cyanide in the solvent says ethanol water. So we see that's a salt. So what are we going to be looking at here? So cyanide is a good nucleophile. The solvent is product is polar, but the fact that this is a good nucleophile and that the alkyl halide is primary points me to SN2 reaction. So, and what's happening here is the attack by cyanide over alpha carbon to get your product. Now notice, typically SN2 reactions, if they happen at a chiral center, the product will have inversion of configuration. However, the center is not chiral, so we will simply draw our product as this. So that is a nitro. We in organic chemistry, we say this is sodium cyanide, but compounds, organic compounds with that group, we call those nitros. Okay, now let's do another problem. Again, identifying what is the reagent, what is it doing in the substrate. I'm going to copy again here, and what I have the following structure. I have bromine here. So now notice the reagent. What is the reagent? We're having here methanol and water. All right. So here we have two nucleophiles / solvent that are miscible actually. So methanol and water. So this is pointing to a solvolysis reaction. But both water and methanol can act as nucleophile. The other thing that is good to see here is that this is a tertiary alkyl halide. And we know that solvolysis reactions go through SN1 mechanism. So what we're doing now is you form the carbocation here, remember, is going to be tertiary. I don't need, in this problem, it's not asking me the mechanism, but anyhow, I am going to draw the intermediate, and it's that. So at that intermediate, you can have the attack by methanol or by water. In that case, I'll say you will have the following. So that initially you will have an extra product, but we will have here either OH or you can also have methoxide. Those two products are possible. I'm not drawing here dashes or wedges because notice that this carbon here is not a chiral center. You have an ethyl and an ethyl. So with that is sufficient. So we should say them because of the reagent. It's likely it is a solvolysis reaction, but we do have two possible nucleophiles, the water and methanol. So that is your product. So your two products. Okay, let's do one more thing here. Let's look at the following substrate. Okay, I need to be reading my notes. And what it has here, a chlorine. Chlorine here. And interesting here, it says, and so sodium iodide, but it says one equivalent. And acetone. So now, if you look at the reagent, good nucleophile. Acetone is polar a product. That condition points to SN2 reaction. Now, what react faster is SN2 reaction is the primary alkyl halide because of less steric hindrance. So here, in this problem, we have secondary halide and a primary. So since we have one equivalent, the product that is going to form is the one that forms faster. So add the primary alkyl halide. And so it's going to be an SN2 over here, primarily, because we have one equivalent. And the other thing is that we don't have a chiral center, so no consideration about the configuration. So simply, you are replacing the halide that is primary. The other stays the same. Well, if the conditions were, excess of sodium iodide, then you will replace most likely, but this is the one that we react first. And so in this problem, we didn't have issues with configuration, so I'm going to do one more problem. And let's erase the first one. And again, notice our analysis have been looking at the reagent and then looking at the structure of the product. So here I'm drawing another, and this time, see, again, need to see what I have. Here I have a metal and a bromide, and condition here is ethanol, and it says 25 Celsius. Now, what do I have here? Ethanol. Is not a good base. It's still a nucleophile. And this is polar product. So your nucleophile and your solving is the same thing. So it is the same molecule, let's say, is ethanol. Condition is polar product. So that points to SN1. And also substrate here is tertiary alkyl halide. So you will form a stable carbocation. So drawing the intermediate here, after the departure of the leaving group, you will have the following carbocation, which we know is tertiary. Now, here you have two metals, and at that center, metal, and ethyl. So you will not form a chiral center because you have two metals the same. So I am going to change this molecule a little bit to add something more interesting to the picture. Now, if you do the attack by ethanol here, you will have possible attack from either side of the plane. So notice that I have now a metal, ethyl, and isopropyl. So I make a chiral center. So your product is racemic. So attack from either side, say that I have metal and OET, and that's an isopropyl, plus the enantiomer. So this is a racemate or racemic mix. That's why I changed the group here to an isopropyl to give you an example in which we are creating a chiral center. But because the geometry of the intermediate is trigonal-planar, you would have the nucleophilic attack from either side of the plane, creating a mix of products, a 50-50 racemic mix.